Lesson 10.5, we're studying tangents. We will use the properties of tangents and solve problems involving circumscribed polygons. How are tangents related to track and field events? In July 2001, Jimsy Monroe of Cuba won her first major title in the hammer throw at the World Athletic Competitions in Edmonton, Alberta, Canada, with a throw of 70.65 meters. The hammer is a metal ball, usually weighing 16 pounds, attached to a steel wire at the end of which is a grip. The ball is spun around by the thrower and released, with the greatest distance thrown winning the event. The figure models the hammer throw event. Circle A represents the circular area containing the spinning thrower. Ray BC represents the path the hammer takes when released. Ray BC is tangent to circle A, because the line containing ray BC intersects the circle in exactly one point. This is called the point of tangency. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So in this diagram, if line RT is a tangent, then OR is perpendicular to RT. For example 1, they said segment RS is tangent to circle Q at point R, so that means it is perpendicular. And they ask us to find Y, which would be the diameter of the circle. Well, first I'm going to call this X, would be a leg of our right triangle. So we can do Pythagorean theorem, 16 squared plus x squared equals hypotenuse, which is 20 squared. And we're going to subtract 256 from both sides of the equation. So x squared equals 144. And normally we'd say x equals plus or minus 12, but we're looking for a length, so we're just going to call it 12. Now x I set up as a radius of the circle, and they ask us to find y, so the diameter y is going to be twice a radius. So it will be 24, and they didn't give us a units. Now they let the converse of theorem 10.9 be its own theorem. If a line is perpendicular to a radius of a circle, then at its endpoint on the circle, then the line is tangent to the circle. And they warn us to never assume that a segment is tangent to a circle by appearance unless told otherwise. The figure must either have a right angle symbol or include the measurements that confirm a right angle. So example 2, we're working on confirming it's a right angle. If it is, Pythagorean theorem should work. So if we do 7 squared plus 9 squared, if it's a right angle, it should equal 14 squared. Does 49 plus 81 equal 196? No. 130 does not equal 196. 6. So this is a no. Okay, same thing with a different diagram. So we're going to check and see if 10 squared plus 24 squared equals 26 squared. 100 plus 576 does equal 676. So this one is a yes. If two segments from the same exterior point are tangent to a circle, then they are congruent to each other. Find x, assume that the segments appear to be a tangent to the circle are tangent. Well, first I can find y. Y equals 10, because ED and EF are both tangent to circle S. So now that we know y is 10, we can substitute 10 in for y in our big tangents. So 10 minus 5 plus 10 equals x plus 4 plus 10. Combining like terms, 15 equals 14 plus x. Oh, golly gee, subtract 14 from both sides, and x is going to be 1. And they didn't make us substitute back in to give a segment length this time, they just said find x, so we're done. In Lesson 10.3, learn that circles can be circumscribed about a polygon. Likewise, polygons can be circumscribed about a circle, or the circle is inscribed in the polygon. Notice that the vertices of the polygon do not lie on the circle, but every side of the polygon is tangent to the circle. Okay, so here's our points of tangency, and this one's going to have 5 points of tangency, and the polygon is not circumscribed because it does not have a point of tangency for every side, and the circle went outside, so that fails too. So just because a circle is tangent to one or more of the sides of the polygon does not mean the polygon is circumscribed about the circle, as shown in the second pair of figures. Triangle HJK is circumscribed about circle G. Find the perimeter of triangle HJK if NK equals JL plus 29. Well, if JM is 16, LJ is 16, and if HL is 18, HN is 18, because there's a point of tangency here, and that's the point where the segments meet. Point of tangent here, point where the segments meet. So same thing here. These two will be congruent. MK is congruent to NK. And JL we know is 16. So that means NK is going to have to be 45, which means MK is also 45. And we have enough to start adding. We could just put our doubles, or if you wanted to, you could just singlet and then double it at the end with multiplication, but just going all the way around the edges, we've got 16 plus 16 plus 18 plus 18 plus 45, and another 45 gives us a sum of 158, and we're stuck with units because they didn't label it again. A line that is tangent to a circle intersects the circle in exactly one point. A tangent is perpendicular to a radius of the circle, and two segments tangent to a circle from the same exterior point are congruent to each other.